Hello and welcome to the JK Feather Garage. As you can probably tell, I've done a bit of work in here since the last video. I have rewired and reorganized everything, as well as insulated the walls and the ceiling. But it's getting to that point of the year where it's going to be hot. In fact, it was 109 degrees the other day, so we need air conditioning, and I'm going to fix that today. I have here this 24,000 BTU Mr. Cool Advantage mini split heat pump system. It's probably a little bit oversized for my modest two-car garage, but admittedly my insulation is not the best and it does get hot here, so I want to make sure I can work out here comfortably year-round. It is a heat pump, not just an air conditioner. So it will provide heating for the few days a year when that might be necessary. Let's start by opening up the box and seeing what's inside.
In the large box, we have the line set, the compressor itself, and a sleeve to run the lines through the wall. And in the small box, we have the indoor unit, power cord, remote control, and instruction manual.
The unit I purchased is actually the Mr. Cool Advantage, which is technically not DIY friendly. It does require some special tools, but as you'll see, I am not in any way a professional, and installing this is definitely not outside of the realm of possibility for a DIYer who's watched a couple videos on YouTube. For the easiest possible install, Mr. Cool does make a DIY kit, which cost about $700 more than the one I bought. And actually at the time I purchased this was out of stock, so I didn't really have a choice if I wanted air conditioning right away. The amount I spent on tools, brand new from Amazon, was about equal to that $600, so it may not have saved me anything this time, but I do plan on installing several more of these on our house and on the sheds my wife keeps building to support her animal habit. So I will save money on each of those. The tools you need are pretty much the same as you would use for any automotive air conditioning repair, and I'll go over a list of them now.
The tools you will need are a manifold gauge set with mini split adapters, vacuum pump, micron gauge, and you will also need a line set cover and optionally a wall bracket if you plan on attaching the compressor to the wall. I'm going to mount my indoor unit right here over my toolbox. I'll start by rolling it away and bringing the unit over to my workbench so I can work on it. First, remove the mounting bracket by unclipping the tabs and removing the screw. Line one side up with a stud and screw it in place. Make sure it's level, and screw in the other side. Add more screws until it's nice and secure. The next step is to install the power cord. The inside end has pins, the outside end has spades. First, pop off the cover plate here and insert the wire through the back. After reinstalling the cover and flipping the unit over, open the front panel and remove the cover plate to access yet another cover plate which contains the wiring terminals. Loosen the 3 screws holding in the strain relief and place it aside. Insert each pin into a hole and tighten the screw. It doesn't matter which goes where, except green is ground. Just remember the order so you can do the same outside. Reinstall the strain relief. The cover plate, and the cover plate for the cover plate. Following the instructions for your unit, mark the location for the hole in the wall. Drill a pilot hole. I then used a long masonry bit to drill through the outside wall, making sure the hole was sloped slightly downwards. Finally, I enlarged both holes with a 3.5-inch hole saw. Slid the line set sleeve through, marked the correct length from inside, cut it to length, applied caulk and pushed it through the hole, before inserting the inner flange and screwing it into place. I could then flip the unit back over, carefully bend the lines straight out the back, secure the bundle with electrical tape, slide it through the wall, starting with the cord, make sure the drain line is at the bottom, and finally hang the unit on the wall.
Now that I've got everything pushed through the wall and I can see where things are going to line up, I have a better idea of where I'm going to put the compressor. I'm going to mount it to the back wall of my garage using these brackets. The only problem I'm running into is that my studs are 16 inches on center and the feet of the compressor are not. So to fix that, I've drilled 3 holes across 3 sets of studs. I'm going to mount 2 sets of strut to the holes, and then I'm going to attach my brackets to the strut and I can put them wherever I need them to be.
First, I needed to cut 2 33-inch sections of strut, and attach them to the wall using 3/8 by 3.5-inch lag bolts. To attach the brackets, I'll be using these spring nuts. Insert them into the channel, twist them into position, and the spring tension will hold them there while I attach the brackets. Next, I verified weight capacity with this fully ASTM certified test before lifting the condenser onto the brackets. The unit came with rubber pads to dampen vibration before bolting the condenser into place. Now I can work on installing the line set. This unit requires at least 10 feet of line without removing any refrigerant, so I'm going to route it diagonally, down behind the unit, and over to the connection valves. I can then bend the lines where I want them, and test fit the cover. It comes in two 5-foot sections, so some assembly will be required. A lot of people use the plastic covers, which would probably be easier. However, in my experience, plastic doesn't hold up well to the sun over time. After rolling out some line set, I have to make this connection before I can install the cover. The evaporator ships pressurized with nitrogen, so if you don't hear a hiss, it means you have a leak and should return the unit. To help the connection seal, apply Nylog to the mating surface of both the flare and fitting. And tighten using 2 wrenches. Do not forget to connect the drain line. With everything bent the way I wanted it, I sealed the hole with spray foam. A light misting of water helps it to cure faster. I then lifted the first piece approximately into position and secured it with 1 screw. I then lined up the side piece, eyeballed it a bit, and put another screw in the top so it wouldn't move. I then installed anchors off camera and screwed down both pieces. Before lining up the bottom, I drilled a 1 1/8 inch hole for the drain tube and screwed the last section to the wall. The drain tube fits perfectly inside a 3/4 inch PVC pipe, which fits perfectly into the hole I drilled. A couple of pipe hangers will ensure that condensate drains in an orderly fashion away from the slab. A bit of caulking will hide my less than perfect workmanship from the world. And it's time to install the end cap. If at first you don't succeed, use a bigger hammer. After applying a quick coat of paint, I needed to do something about the open end. I traced a template onto some cardboard, transferred it to a scrap of metal, made room for some flaps, cut the piece out, added a 7/8 inch hole for the power cable, and a 2.5 inch hole for the line set. Before bending it in my vise. And applying some paint. When that dried, I sliced open a piece of irrigation tubing to use as a grommet, and placed it around the hole to protect the line set. The other hole will accommodate a flexible conduit connector. I then slid the end cap over the line set, pulled the cable through with the help of a wire, and screwed the cap into place. It's finally time to remove the electrical cover and install another connector. I then pulled the cable through a piece of flexible conduit and attached the connectors at both ends. Before connecting the wires in the same order as inside. To run the power wires, I first put a 90-degree bend in a piece of 1/2 inch EMT conduit, which will attach to my panel through this fitting. I need to bend an offset to allow me to clear the existing conduit and still use a pipe hanger. There are apps that will calculate the necessary bends if you provide the measurements. In my case, I need to make two opposite 22.5-degree bends, 3 1/4 inches apart. I'd say that came out pretty good. Nothing that a couple of pipe hangers can't fix. While messing with the conduit, I managed to kink one of my refrigerant lines. I'll cut them off for now to get them out of the way and deal with that later. After attaching a flex connector to the end of my conduit, I pulled in 3 10-gauge wires, 2 hots and a ground, before using another piece of flex to attach to the condenser. In my case, a disconnect box is not needed since my panel is only a few feet away within line of sight. I've installed spade connectors because that seems to be what the terminals were designed for. Green goes to ground, blacks go to L1 and L2. That's it for the electrical, except hooking up the 30 amp breaker in the panel. For detailed instructions on installing a circuit breaker, please see my previous electric car charger video. Finally, it was time to deal with the refrigerant lines. I cut back as far as I could to straight, undamaged copper, removed any burrs left over from the cutting process, blew out any debris with compressed air, remembered to install the flare nut, inserted the tube into the flaring tool, making sure it sticks out about a 1/16 of an inch, slid the tool over and tightened down the clamp, and turned the handle to create a flare. You will feel it release tension when you're done and can screw it back out. Removing the tool will reveal a shiny, completed flare. I'll be using these flared elbows to replace the kinked section of pipe. After applying nylog to both mating surfaces, I tightened both ends by hand, before connecting the other side to the compressor. And tightening with a wrench. I then tightened both sides of the elbow and repeated for the smaller line. I am now ready to pump down the system and check for leaks. On a car, the red hose would go to the high side, but it's not being used here, so I'm connecting it to my vacuum gauge. The service port is located under this cap and connects to the blue hose through a mini split adapter. The yellow hose then connects to your vacuum pump. To open up the gauges, screw both valves all the way out and turn on the vacuum pump. You'll notice the pressure on the gauges start to drop. The micron gauge will also start to drop, although more slowly, as air, moisture, and other contaminants are sucked out. The standard for a refrigeration system is 500 microns, which I just reached, but I'm going to take it down a little lower just for good measure. Fully close the blue low side valve before shutting off the vacuum pump, or you'll have to do this whole process again. After making sure the pressure doesn't rise, which would indicate a leak, remove the cap from the refrigerant valve. Using a 5mm Allen wrench, release a small amount of refrigerant into the lines. This will ensure no air is sucked in when disconnecting your gauges. Reinstall the service valve cap before fully opening both valves to release the refrigerant. Go ahead and reinstall the valve caps. Turn on the breaker and test the unit. You can barely even hear that it's running.
I don't know if you can hear the fan, but we're definitely blowing cold air. This isn't going to be a very good test because it's actually cooled down a bit outside, and I actually have to leave right now, so I can't leave this running and check the temperature. But so far, everything seems to be working, and I'll check back on it tomorrow. Alright, so it is now the next day. It is currently about 101 degrees outside. Going into the garage, I have set up this little thermometer over here. It's currently 88 degrees, so the insulation is doing something, but I do need more cooling than that. When you turn on the air conditioner, you'll notice the little vent lever comes down into the position that you can actually set it at using the remote. In my case, I set it so it blows directly on me while I'm sitting here at my workbench. So if I'm working on a project or something real quick, and I come into the garage, I can have cold air blowing on me without having to waste the energy to cool down the entire space. But that is what we're testing today, how well this does cooling off the entire garage. So I'm just going to let it run and check back on it in a couple of hours. So it's now been about 2 hours since I started running the air conditioner. Outside temperature has actually increased to about 104. The compressor is still running normally. The lines where I can feel them are quite cold. But the temperature on the far side of the garage is still 77. This may mean I just need a fan to get some airflow to help move stuff around in here. I am going to let it run a little longer though and see how low it goes. And we're now down to 75 on the far side of the garage, and it's quite comfortable over here. I might add a fan to help circulate the air a little bit, but I do need to keep in mind that if I'm actually going to be working on something out here, I also won't have 2 cars parked in the garage, which will probably help with airflow as well and to keep a more uniform temperature. So overall, I'm going to call this installation a win. If you found this video helpful, don't forget to like and leave a comment below and subscribe to this channel for more content. Thanks for watching!